Hi, good morning. I hope you all are having a good time. We'll start. I am Faiz, and there are three more co-speakers along with me. Shuva, Muthu, and Ashutosh is here. Shuva and Muthu are not here, so okay, not an issue. I mean, how many of you guys are familiar with writing applications in OpenDL? I mean, not cluster-aware application, but in general, coded. Yep, awesome. Fine. Those of you who have not written, it's not an issue. We won't be, since this is not an hands-on session, and also it shouldn't be any problem. Okay, so. Fine. Any idea about distributed systems, raft protocol in general? Any one of you? Okay. You have a fair idea of raft and raft protocol, distributed systems in general.
So I have worked on distributed systems.
Okay.
Using the and other
Okay. Okay. Huh? Okay. All right. So I'll tell about myself. I graduated from BITS in 2015 and I joined Ericsson. So I'm basically 1 year experience. Okay. What we are going to do is we'll divide, since this is a 3-hour long tutorial or a talk, what we'll do is we'll not keep the questions for the end. If you have any doubt, any query, you think you are not understanding, you can stop me right there and we'll clear it out. Okay, you don't have to wait till the end. And what we'll do is, first hour we'll talk a bit about theory. The first hour we'll talk about theory and foundations and all. Second hour we'll go into best practices and we'll do a code walkthrough of, we developed an application at Ericsson to demonstrate kind of what are the best practices. So we'll do a code walkthrough of that, and then the last hour is for more of do's and don'ts, and in general what practices you should follow. Okay. So fine, we'll get started. Yep.
So okay. The application that we're demonstrating or showing here is something that we developed in Ericsson itself. Because like many people.
Yeah.
So many people find it difficult to start using the ODL infrastructure to write a cluster-aware application. Right? So the goal was to write a reference application which is simple enough, but shows what are the different ways in which you can leverage infrastructure. So not only leverage, but leverage in a way that makes it scalable. You can write it high performant, make it highly available, so that if there is a fault, it can the infrastructure can help you recover that system. So it is under that project that we developed this one, and now we want to showcase it to other forums. I think we already sent out a mail showing what is a reference, what are the things that it does. This is more in-depth view of that application.
Okay. So let's set the, what happened? It has to move forward, right?
Getting stuck.
PowerPoint got stuck. Okay, just give me a moment.
give. So the structure will give a theory of how the data store in ODL, how the data store in ODL is implemented. There are multiple ways. There are different implementations of it. There are different implementations of it. There are ways in which you can use it as a data store, as a notification system, and there is a way in which the same thing can be leveraged over a cluster. So what we are going to focus here is how do you write a replication so that at application level it is seamless, whether it's a single node or a cluster-wide thing. But you need to use a proper APIs. You need to use a proper constructs. You need to be aware of few nuances of what it means when you're going to write in a cluster-aware manner. Right? So there might be something, say, related to the timing of the events that you're going to get across in a cluster node. So we'll probably detail on that one.
So the thing is, in OpenDaylight, this capability of clustering comes out of the distributed nature of the data store. Okay, so data store is kind of the central or the core piece in mdsal infrastructure. Basically, data store is not just to put your Yang instances in it, but it's also used as a communication bus or for multiple apps to communicate with each other via notifications. Okay, so to write cluster aware applications, you need to have a little handle on how the data store works. Okay, and to get a handle on that, you need to know a bit about Raft. So two things which we are going to cover is overview of Raft and mdsal data store. Routed RPC, entity ownership service and cluster singleton service are kind of, we'll go over them briefly, but I won't go into the APIs and how to basically in the reference app I'll show as in how it is used, but we won't go in depth. Okay, so main thing that we'll be focusing on is the data store, and we'll do a bit review of what Raft is. Okay. Yes. No. Okay. So in OpenDaylight, right now the assumption is your cluster is symmetric. Okay, and it's not in active standby mode. All the three nodes are active. Okay, but yeah, one of the node will be doing most of the work. But so we'll talk about that once we go in Raft. But yeah, the assumption is it's a symmetric cluster, and all the three nodes are active. Okay. All right. So we'll first talk about Raft without bringing in the data store, as in what is Raft and as in the general protocol. Okay, so Raft is a protocol for distributed consensus. Now instead of going into the technicals of what is distributed consensus and all that, basically what we are using it for is to replicate the state machine. And for us, the state machine is the data tree. So you guys know about data tree, Yang data tree. Okay, so that Yang data tree is actually replicated across all the nodes. So during this talk, we'll assume that we have 3-node cluster, okay, and the data tree is fully replicated across all the 3 nodes. Okay. So fine, we'll start with.
So maybe one more thing. Yeah. Are people familiar with what is Yang? Okay, because Yang, whatever you model in Yang, that information gets stored in the data tree as is. So if you have a Yang structure, you have a container and list, so that will get stored in the data tree in the same manner. I mean, if you have any questions, please feel free, because we are assuming something. If people are not aware of it, please feel free to ask. It's better that way, so I mean, it gets clarified for others as well.
Okay. So Raft is a fairly, I won't say it's a very simple protocol, but it was created in response to Paxos, Paxos is generally used in industry for as a distributed consensus protocol, and Raft is a kind of a simplified protocol as compared to Paxos. Raft has only two key roles to do. One is leader election and another one is log replication. So we'll go through why it is designed that way and how it does leader election and log replication. Okay, and the implementation of Raft is also fairly simple, or it requires only kind of two RPCs to which you need to implement, and then probably you can also implement Raft on your own. Okay, so first is leader election. Okay, so to replicate the state machine, you need to kind of, for example, I mean, we are assuming that it's a 3-node cluster. Wherever your operation lands on, let's say on node 1, you want to do a write. Okay, let's say you want to put x equal to 5. This x equal to 5 has to be replicated on all the 3 nodes in the cluster, right? Someone has to coordinate these writes basically. It cannot be like you write x equal to 5, someone else is also writing x equal to 6. Which write goes in first, as in, and since Raft replicates your data consistently, as in by consistent what I mean is if you try to read, or if multiple clients try to read, they'll all get the same answer. It won't be like one client gets x equal to 5, other client gets x equal to 6. Okay, so to replicate the data consistently or to provide a consistent view of the data, you basically need one node to coordinate your operations. So what Raft provides is, Raft provides a way to elect one of the nodes in the cluster as the leader. Okay, and all the operations, whether they are writes or reads, are forwarded to the leader basically. So how the leader election works is, it's actually pretty simple. When you bootstrap a Raft cluster, all the nodes in the cluster come up as followers. Okay, and they wait for heartbeats from the leader. Since there is no leader in the cluster, none of the nodes will receive the heartbeat. So what happens is, eventually these followers will change their role to candidate. Okay, so you can see times out, follower goes to candidate, and it starts an election. Okay, what the candidate does is, it asks for votes from its peers. Okay, and the peers are gonna basically, whenever they receive a request vote RPC, they are gonna respond with the vote. Now the thing is, the peers can only vote for one guy. It cannot be like in an election you don't vote for more than one person, right? Similarly, the peers are gonna vote for whichever candidate sends them the request first. Okay, once the candidate gets enough number of votes or the majority of votes, it becomes the leader. Okay, receives votes from majority of the server, becomes the leader. Now it can happen that multiple candidates, multiple followers can become candidate, right? So to prevent that situation, Raft uses randomized timeouts. So this timeout is not fixed. It's not like all the followers will become candidate in if they don't receive in, let's say, 5 seconds or something like that. Okay, so maybe one follower will become candidate in 3 seconds, another follower will become in 5 seconds, and the third one can become candidate in 7 seconds. So you randomize these timeouts so that only one of the candidate, only one of the follower becomes candidate at a time. Okay, so follower becomes candidate, goes, and since it becomes the candidate, it is going to send the request vote RPC first. Others will receive it, vote for it, become the leader. Okay, any questions? Yes, so the thing is, in Raft, when you bootstrap the cluster, each of the node has the peer IDs, or basically IPs of its peers. So it knows beforehand the number of nodes in the cluster. Okay, so majority would be n by 2 plus 1. Okay, so it's not something that it will change. It's fixed as n by 2 plus 1. So in case of 3 node, you need 2 votes to become the leader, right? Any other question? As in, okay, yeah, we'll go into it. So in ODL cluster, it's not that the controllers are forming the cluster. It's the data store which is forming the cluster, and in the data store you specify that this data tree is replicated to these nodes, and you specify their IPs explicitly before bootstrapping, as in there is a module shards.conf file. When you will make a distribution.zip, there is a module shards.conf file is there. In that you specify what all members are and where your replicas are supposed to go. Okay. Yeah. Okay. So in the first case, right, follower, when it goes to candidate, it turns into a candidate because it has not received heartbeats from the leader. Okay, but the thing is, other followers have also not received heartbeats from the leader, right? So others will also turn into candidate. Now if let's say worst case is all the 3 guys turn into candidate, right? I mean, I am also candidate, my 2 peers are also candidate. Obviously I'm not going to vote for them, right? So to prevent these situations where all the followers become candidate or 2 followers become candidate at the same time, what they do is they have randomized this timeout. Timeout is the maximum time I can be a follower till I receive the heartbeat from the leader. Okay, so one node will wait for 3 seconds, another one might wait for 5 seconds, some might wait for 4 seconds, something like that. Okay, so the follower which becomes candidate first is gonna start the election. Okay, that is why they have randomized the timeout. Also becomes? Yeah, yeah. So yes. Yeah. Yep. Yes. So if 2 candidates, let's say, come up at the same time, they won't be able to get the majority vote. I mean, both of them cannot get the majority, and it might be possible that so since both of them do not get, they will again time out and then start a new election. Okay, so when they time out again, that timeout is also randomized. So eventually the election will converge. In case of odd number of nodes, it converges pretty quickly. In case of even number of nodes, yes, it might take time. Okay.
One comment here. So unlike many data stores which allow you to go for an eventual consistency kind of model, the data store and the clustered data store, and which is based on rafts, goes for a strong consistency model. What that means is that if any node has written a write and it is acknowledged by the data store, any subsequent read from any of the nodes will get you that value. It is not eventual consistency model that is followed here. What it also means is, if you are aware of the CAP theorem, it basically says that you can trade off between consistency, availability, and network partition tolerance. So what the raft goes after is consistency and partition tolerance. You can partition the network, the connectivity between the nodes, and the system will still perform in the proper manner. What it does not handle is that if you break the connectivity between, say we have a 3-node cluster, and you break the connectivity between all 3 nodes, so all the 3 nodes may be up, but the data store will not function because it cannot elect a leader, right? So it will not be highly available system in that manner. I mean, some other data stores allow you to do that, where when they form the cluster, they do a merge kind of thing. Raft does not support that model. It supports a strong consistency and network partition tolerance. So you never have a notion of a split brain, that two writes on partitioned nodes are getting acts. They will always get an act only from one leader.
This transition, you said that the follower gets is marking the leader.
Yes.
So Ashutosh is looking on the other,
Hmm.
and we have the first one, as you said.
Yeah.
You have the first node, maybe it turns into a candidate.
Yeah.
So it goes and votes for itself.
Yes. I mean, if I become the candidate, why will I vote for someone else, right? So yes. So if I am a candidate, I'll vote for myself and then just stop. Okay. So once the leader is elected, now you have one of the nodes to coordinate all your operations, whether they are reads, writes. Okay. So next is the log replication. Now what we want to do is we want to replicate the data tree, right? So to replicate the data tree, first what RAF does is it will replicate a log, and from that log it creates the data tree. Okay. So basically log is nothing but whatever operations you send to a RAF node. Okay. I mean the operations which will modify the state machine. State machine here is your data tree basically. So any operations that is going to modify the data tree, what it does is it puts it into a log, okay, and it asks other nodes to basically replicate that entry. Once that entry is replicated to the majority, it is committed to the log and then it is applied to the state machine. Okay. Now, I mean, it is a lot of stuff to digest at once. So we'll start with the, okay, so client sends a request, let's say put x equal to 5. Okay, let's say it's a key value store or something. Okay, I want to put x equal to 5. So client sends a request. Now request can land on either the leader or on the follower. Basically clients are not aware that which node their writes are going to land on. Okay, so it can land on the follower or on the leader. Now if it lands on the follower, I mean it's simple, the follower will blindly follow it to the leader. Okay, so this operation x equal to 5 is forwarded to the leader, and if it lands on the leader, then there is no problem. Okay, so what the leader will do is leader will put this operation into its log. Okay, so log is nothing but an append only file. Okay, in that append only file it will append a log entry in which this operation will set x equal to 5. Okay, next what it is going to do is ask the other followers to put this entry into their own logs. So each and every node will basically have a log. Okay, so leader will ask to replicate that entry to other nodes as well. Okay, once the majority of followers reply back that yes, we have received this entry and we have put it into the log, what leader will do is it will commit that entry. So just because an entry is sitting in the log doesn't mean it is ready to be applied to the state machine. It needs to be committed first. Okay, so once the majority of followers reply back that yes, we have added to our logs, what leader will do is it will commit the entry, and then after committing it, it will apply it to the state machine. So once it is applied to the state machine, leader will ask its followers also to apply to their respective state machines. Okay, and hence the followers will also apply x equal to 5. So in this way your whole let's say it's a key value store, the key value store just gets replicated to all the 3 nodes. Okay, any, yeah. Okay, so if a follower has some trouble applying entry, then the follower is going to reply false basically. So okay, yeah. So RAF basically has 2 RPCs. One is request vote and another one is append entries. So these are RPCs, they require a response back. Okay, so when the leader calls append entry RPC on its followers, if the follower is not able to apply it due to any reason, it is going to reply with false, that I am not able to apply. Okay, so you basically cannot get a majority consensus from your followers if your followers are not able to apply that entry. That happens actually. So it can happen in a raft cluster that there are two leaders at the same time. Now one of the leader is will be a stale leader kind of, which is from the previous term. Okay, but it is not aware that another leader has been elected. Usually this stuff happens if you have like a 15 node, 20 node cluster, and if you have huge network latencies or something like that, this is very much possible. Okay, so the stale leader keeps on sending append entries, okay, and the followers will reply false, 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 because the followers see that no, there is a new leader out there who is sending me append entries, I cannot take from you. Okay. As in, okay, so when the lead, okay, so it is definitely possible that the leader goes down due to some issue or gets disconnected from the cluster, right? So this stuff starts again. Okay, now the followers are not getting heartbeats from the leader basically. So one of the follower becomes the leader then.
So Raft is based on a quorum-based system. As long as you have more than half number of nodes talking to you and considering you as a leader, then the system will continue to move forward. So in order to have a protection against single point of failure, we need to use 3 nodes, so that even if one node goes down, the 2 nodes can talk to each other and still maintain a quorum. But if you go for a 2-node cluster, in a Raft system, then it will not be protected for a single fault.
Because in 2-node cluster, the quorum will be n by 2 plus 1. N by 2 plus 1 is 2. So basically there is no, you cannot tolerate any failure in a 2-node cluster. So it's recommended that minimum you need 3 if you want to tolerate faults. Okay, yeah. Yes. Why not we? Okay, so the way we have implemented is the clients should not be aware of who the leader in the cluster is. Basically, the abstraction is provided in such a way that the whole cluster looks like one entity to you, as in it should not appear to the client that there are 3 nodes, 4 nodes, 10 nodes, and there is one leader in it. Probably if I change this Raft protocol to something else, let's say I don't use this data store, I go with some other data store, something like Cassandra and all, where there is no concept of leader and follower. Writes can land upon any of the nodes, okay, and that node becomes the coordinator for that write. So if I go ahead and replace this, then I'll essentially break the contract, right? So now that there is no concept of leader and follower, where will I land my writes on, right? Yes, that is there. So I mean,
let me. So there are 2 parts to writing an application. One is application logic part, and second is storing that information in a data store. If you have multiple nodes, you can still go ahead and do your application level logic on these nodes. So you have a scalability part. So you can do your application logic in 3 of the nodes. Only when you want to store that information into a data store, that part gets serialized and sent to leader. And moreover, we'll probably come to later, you can have multiple shards. So shard is a unit of the data store. And for each shard you have leader. It is not that there's a leader for the whole of the data store. So you can partition the data store into multiple shards. Each shard gets a leader. So if you spread out this shard functionality and you have distributed leaders, then again your load on the data store gets distributed. So you are able to write a distributed application that runs on multiple nodes instead of writing just on a single node.
okay, so I'll come to that. Yeah. Yes, yes, yes.
Yeah,
So you will not have one Raft cluster running. You will have multiple Raft clusters running. I was reading yesterday an article about CockroachDB, in that they have ranges of keys, right? Each range will form a 3-node cluster. And if you have thousands of ranges, there will be thousands of Raft clusters.
so it is configurable in ODL how many shards you want, but for each shard, you will have this whole thing replicated. So each shard will have a leader and multiple followers.
Yes. And to your question, why don't we first figure out the leader and then directly communicate to it? It's basically not, I mean, the abstraction is provided in such a way that it is agnostic to, that it has to land on the leader. You can definitely do it. So what you can do is, one simple way is, let your write land on the follower and let the follower reply with who the current leader is, and then just the client can just forward it to the leader, right? Huh. That is what it is doing right now, no?
So I think
But then it is equivalent to this only. No, that abstraction would be doing the same stuff which your node is currently doing. You are saying the logic of forwarding should be abstracted out into some other layer. Yeah. Yep.
So
Yeah.
So just to add on to that, so the way the APIs are written, it is not tightly coupled to a raft kind of data store. There is an evolution path where you may have data stores which do not follow this strong leader-follower concept. Right? As long as applications are able to handle, say, eventual consistency, the same APIs, the data store APIs can be used. So we want to keep those APIs wide enough so that other kind of data stores can be plugged in into that model. It is so currently the cluster data store is based on Raft, but there's already an activity going where we are planning to have a notion for pluggable data store. So you can replace the Raft and put your own data store, and whatever consistency model that data store provides, if your applications are able to be okay with that model, you can use that model. So the whole idea is that you are able to write a scalable application so that some application logic can happen at different nodes, and the data store part again is a layered part. The APIs are generic enough to support other kind of data stores as well.
All right. Yes. No. A particular yang will. Yeah, basically what you can do is you can shard your data. Is that what you want to do? Like, for example, inventory data will go into inventory shard, topology data will sit in topology shard, and then these shards can be mapped onto nodes.
Okay, so my question is, how will you define this particular yang belongs to inventory data?
Yeah. So when you will, when you are defining the yang model, you specify the module there, right? So it will be part of the inventory, or whatever model you define. Yeah. Yeah. Yes. No. Okay. So like Ashutosh said, this is a strongly consistent system. Okay, so and it is partition tolerance also. So if you have heard about cap theorem, it will, okay, so cap theorem basically, so CAP are consistency, availability and partition tolerance. Okay, so we have chosen C and P. Okay, we cannot have A basically. You can pick two. Okay, it's just like physics. You have these theorems and all, no? So you cannot get around it. It's kind of like that. So we have chosen C and P. So we sacrifice on availability, which means that during a leader election, if that process is going on, if there basically then there is no leader available, right? You cannot write to the data store. The data store will throw some exception saying it's not available or something like that. Okay. You retry again basically. You usually it will converge within, I mean, a second or so. Okay, it won't take much time because these timeouts are in order of milliseconds. So it won't take, I mean, an hour to converge back. Okay. Yeah. Yeah. By the way, he is Muthu and he is Shuva. Okay, so okay, so
I have one question.
Yeah.
In this followers, assume the leader is going down. So what is the chance that a particular leader gets voted more than one? It gets more than one vote. What is the possibility? Because if every candidate start voting to itself, I don't understand.
no. What is?
You assume that the follower becomes one follower becomes a candidate.
Yes, so that randomized timeout is there, no? So only one follower, or it will try that only one follower becomes
Candidate and
the candidate.
So the algorithm is something like which follower becomes the candidate first is always the leader.
No, not always like that. So okay. So in request vote RPC, it's not a blank RPC in which you ask for votes. You also send what is the length of your log and all. So the one who has most of the entries is probably ahead of other nodes in the cluster. So it should become the leader, because what leader does is it will try to force its log on the followers basically. So if you elect a follower, or if the cluster elects a follower which probably has less number of entries or entries which are not committed, what it will do is it will ignore the other entries which are there with the other followers, right? So yes. Now why these followers lag is, if you notice, the the operation which the log entry which is replicated, it needs to be replicated to the majority, and the leader is going to commit it. Okay, the leader will replicate to everyone. It's not like other nodes will be left out, but to commit it, it requires only majority ACK. It means that some followers will lag a little behind. Now if they become leaders, basically what they'll do is they'll try to force their logs on the followers, and if the followers have committed entries ahead in the log, basically they will be overwritten. So that cannot be allowed, because once an entry is committed, it is applied to the state machine. No, it will become the candidate, but when it asks for votes, it will not get the vote. No, that is only the randomized timeout. Okay, so if a follower stops receiving heartbeats from the leader, it will become a candidate. There is no other criteria. But to get votes, the criteria is you need to have log. So basically, if you guys are connected to the internet, you can get this paper. Okay, this is the raft paper in which all of this stuff is described.
Yeah, of course, you can also
Okay.
subscribe to, there is a, because since Raft is relatively a nascent protocol, I mean, it's hardly 2 to 3 years old now. There are some optimizations which are also being suggested in various researches, and there's a discussion forum in Google. So, to the question of, like, say, why not that, like, say, the candidate predetermine whether it can actually solicit the votes. There are some optimizations which are there in some of the implementations, but as with always, all options, I mean, they will also have other false sides. Now, like, say, we can get into a false positive modes. So it is always the nodes which are actually voting for the candidate or the potential leader is the guy who decides that, okay, I mean, should I vote or not. There are some other optimizations wherein, like, say, whether there can be spurious leader elections, like, say, there can be, if it is a non-homogeneous cluster, there can be a Byzantine attack wherein, like, say, I mean, somebody can spoof saying that always I want to become a candidate and disturb the cluster. So there are some optimizations which are actually proposed for improving that situation also.
But yeah, I mean, you always deploy ODL controller in a very controlled environment. So you won't have these Byzantine servers running around who will mess up your cluster. Okay, yeah.
You mentioned all the read operations are also forwarded to the leader.
Yes.
So instead they can be read from the local data
Yes,
store.
yes, yes. Now, the first, I mean, we want to provide a strongly consistent data store, okay. Now, if a follower is lagging, I will not have a strong consistency. I will have eventual consistency, because let's say I read from the, I do a read operation on the follower, okay. Let's say 2 clients are reading at the same time. One whose request lands on the leader will get the latest data, but the client whose request lands on a lagging follower will get stale data, right?
See, even leader commits after some time, right? So once we get that response from all the followers.
Yeah, so by the time the leader has not applied to its state machine, everyone else also has not applied to their state machine, right?
Clients can retry, I mean, based on the
Yeah,
current
clients
state
can, yeah.
machine.
So there, I mean, this is actually one of the proposed optimizations in which, since I mean, I can keep on retrying and I can basically keep on polling the node for latest data. So I don't have to forward the reads to the leader actually.
So I think it depends on the kind of applications
Yeah.
that you have written. So if the applications can tolerate eventual consistency, that I wrote something to a data store, I'm reading it, I might be getting a stale data. If you're, and I will retry and retry. If your applications are built like that, then yes, the followers, you can read from the followers. But if you always want that whatever I have written on the data store and has been agged, any subsequent read on any of the node is going to get me that data, then you even have to go to the leader.
But applications won't be having that control, right?
No,
My
not the application.
application is
I'm
not
saying the contract with the data store, right? So currently the contract is strong consistency. If data store says it has been written, any subsequent read to the data store will get you the latest value. So it restricts the system in some way, right? But it makes the application life much easier. But yes, if the applications can support or do not require such strong consistency, then reading from the followers can be done. And I think there is a proposal in ODL to allow reads from the followers. But again, it depends on whether the applications can handle such lagging data.
For example, I mean, if you take the port state, let us assume that there is an inventory in which is reflecting the switches and the ports associated with the switches. If the application can tolerate, like, say, for example, but I mean, what exactly will be the criteria for retry in that case? I'm just reading, say, okay, this is switch A, get me all the ports. Now I'm initiating this from the follower. Now I get, like, say, 24 ports. Actually there are 32 ports. On
Because
that basis, I mean, the retry could be actually even incorporated.
there is some other client who is adding these ports actually, which will be ideally be, OpenFlowPlugin, OVSDB, something, right? So they'll be adding this stuff in the inventory. By the time it gets synced to all the nodes, it will take some time, right?
Yeah.
Now, if you read from the follower and a follower is lagging a little bit, you will get stale data.
So basically, I mean, this Raft is coming under the category of the consensus protocols. So consensus protocols, I mean, you have some of you might have even would have worked with Zookeeper. Zookeeper's protocol is ZAP. Zookeeper Atomic Broadcast, and Raft falls under the similar category, and Paxos is another consensus protocol. All these cases tend to actually provide a consistency as the prime goal. So it will never try to compromise on, like say, what data I read from. I mean, in the sense that data what is being produced by the data store to the client is always consistent, and that can be ensured only by the authoritative current leader. So that is the reason why, I mean, even the reads are from the followers. But yeah, as Ashutosh mentioned, there are optimizations. If you take some of the other implementations, there are few implementations which use Raft as a protocol. One is, I think, I mean, recent version of ETCD actually.
Yes.
Yeah, so ETCD is another alternative for Zookeeper. I mean, you can keep a cluster-wide configuration, and then you can just look at it. I mean, it can serve as a consistent lookup mechanism. Now, latest version of ETCD, if you see, you can configurably switch whether you want to read from the follower or not.
But like we can do some kind of optimization, like the two-step read. Like instead of reading whole data from that, one you can check for the consistency and then read the data.
Can you repeat that?
So what I'm saying is like we can do two-step process. Like first check for the consistency instead of.
Yeah, so basically it would require a knob which will say, okay, I want eventual or I want strong. If it is strong, then it always gets forwarded to the leader. And if
What I'm saying is like we can check for the consistency first, like if followers and reads are consistent, then start from the followers.
Yeah, but then in that case, you will have to broadcast that request to a lot of other clients. Not necessarily. So, for example, in the same, if you take a 3-node cluster, right, you have written something and data source says it's act, that's written. Now, suppose your client gets disconnected. If you even go for a read, you will get an error. You will not get an old value. Because data source says, I do not know now who is the leader. It has some modification. No, so the API doesn't change. It is the same API. You write and you read. You will start getting errors automatically if it is not the latest value. If I cannot guarantee that this is the latest value, I will not give you any value. That is the API that has been defined till now. So to make applications life easier, because typically people tend to write with that kind of notion. And the whole idea is that you can write an application. I mean, if you keep these things in mind, you can write an application that works on a single node. And if you just change the underlying data source to a cluster, your application does not require any change. The same model can work in a cluster also, maybe up to 10 nodes. Okay, no application change required.
Also, that could be a trade-off, right? See, I mean, as with any choices, I mean, architecture is always a bunch of trade-offs. What works best for you matters. If we have to do some level of semantic consistency check mechanism, I am incurring one more network hop cost.
not only that, let's say you determine, okay, that fine, the follower is consistent with the leader, okay, and then so it's not like there is only one client who is writing, reading, everything, right? So if there are two clients, okay, one is reading, another one is modifying. So the client which is modifying, its data will take some time to replicate, right? Now this follower from which you are reading, from which you know that, okay, my reads are going to be consistent, but now you cannot have that assumption, right? It can start lagging again.
And I think this one more comment, probably little bit deviant, but the interface for Raft is not an application state. What it guarantees is that log is getting replicated to majority of the nodes. What that log means is something that application has to decide. So even if you consider data store as an application, and Raft is a part where just the logs get replicated, right? So if you see, it is just logs, logs, logs. What those logs means is something that the consumer of the Raft is going to determine. Right? So you cannot say, oh, this is a read. Now Raft tell me whether I'm in line with the leader. Because Raft does not understand what the application data tree is. All it needs is, oh, there was a log. I have replicated a log. That's it. My job is over. Right? What you do with that log, putting it in the state machine, applying, is something that the data store application is going to do.
Yes. Okay, so leader, which was your last operation? It was, I mean, the election is happening based on the log. Okay, so in your state machine, what data is there, RAF doesn't know about it. Okay, so what I mean, if you are saying that no.
So the idea is that the data stores gives you an ACK. The data is stored only when it has been ACKed by majority of the client, of the nodes. So once all the majority of followers have said, yes, we have done the commit, only then the leader will give you an ACK, the data has been done. Otherwise, you will not get an ACK. And after that, subsequently, if the leader dies, any of the nodes can become the leader. But again, like we said, the leader with the maximum commit index, he is going to become the leader. If he gets a request for a leader from someone else, he's going to deny that request because he already has data that he has committed. So he's not going to allow someone else who is lagging to become a leader.
Basically, the log will stay consistent across all the 3 nodes at any point in time, basically. So, and if you are reading from the log and applying those entries, naturally your state machine will also be consistent. No, it will only sync its log.
As far as the log Raft is concerned, I mean, as Ashutosh mentioned, log is its focus. So, I mean, how do I so there are two things, right? Like say, I mean, let me slightly deviate and then go to a totally different example. So, some of you might have heard about the term event sourcing and command sourcing, which is now becoming more or less a good architectural paradigm for most of the distributed systems. So, let's take your bank account. At any point in time, you want to get the balance. How exactly the computation is done? It's not that in some core database, it's not that your bank balance is updated, right? Your bank balance is nothing but a sum of credits and debits. Now, always the system will log the credits and debits, and then it will give you the balance based on the sum total of the computation. So you can think of these transactions of debits and credits as your log entries, and your final balance is nothing but the state machine. So what will happen at any point in time? I mean, you can play back, you can rewind, you can do all those things. Of course, I mean, those facilities are not there. So Raft follows that kind of philosophy wherein it's basically a log structured system. I mean, in the Linux world, I mean, you can draw some level of parallels with JFFS, journaling file system, right? So it's like a set of actions which affect the state of an entity. Now I store the actions, I don't store the state against that entity. So that way, I mean, that has got a lot of other good properties as well as it has some false side. For example, if I have 1 million transactions, what will I do? My bank will every year it will roll over and then it will update the balance, and then for the next year only it will maintain the transactions. So there are constructs like
Snapshots, yeah.
keep the state, and then like say keep some buffer amount of entries which can be applied at any point in time so that the recovery can be realized, recovery of the state. So state itself is not the concern of Raft.
All right. Any other queries? Yeah. Yes.
say some 11 nodes. So say I have defined some 4 shards.
Yes.
So each shard is replicated on each of the node?
No,
or,
so that is what in module shards.conf, in that file you can specify which shard. I mean, let's say I have 2 or 3 shards, okay, let's say we have 2 shards, shard 1, shard 2. You can specify where the replicas of shard 1 are going to be mapped on. So you can map shard 1 on probably node 1, 2, 3, 4, 5, shard 2 on node 6, 7, 8, 9, 10.
Suppose say tomorrow if we introduce nodes dynamically, or say
Yes, yes,
shards
yes.
can
So
be created
currently
dynamically, so
that functionality, I don't know how stably it works, but you cannot add nodes dynamically.
I mean,
Right
there
now.
is a proposal.
Yeah, there is a
and
proposal.
If you're interested, I think you can chip in and help maybe
Yeah.
Because
work on that.
currently there is the dynamic node addition capability is there, but it has got some severe limitations. So it is officially not part of. So it is. There is nothing like say elasticity. I mean, you
Yes.
are basically talking about the elasticity of the.
Before bootstrapping, you need to specify everything. What all members are there, where the replicas are gonna sit, all that you need to specify. If you want this dynamic membership, it's discussed in the paper. It's nothing but another operation on your Raft cluster only. So it's actually a complicated topic. You can go through the Raft paper. It talks about how this dynamic membership works. Basically, the guy who has written this paper, he has a thesis also. You can go through the thesis that describes a whole lot of optimizations, and he discusses there in much more detail how this dynamic membership and other stuff works.
And there are some
Yeah.
proposals which are also coming up in OpenDay, right? I mean, for
Yeah.
improving this elasticity capability. So I mean, that's more like a topic on discussion.
But I mean, as we go in subsequent slides, you will realize that probably you don't need a 10 node cluster.
maybe
Okay.
one last question on this. I mean, say for this Raft election to work, right? Say at least the shard should be replicated on 3 nodes, right? For this election to happen at
Yes.
shard level.
No,
Suppose say user missed to configure, say he configured just to replicate on 2 nodes.
Then it's
will
only
miss.
2 nodes who will be forming
No,
that
that's what
cluster.
I mean, because it is given to the user, he may.
You cannot expect the controller to be
why is
intelligent
this-
enough to.
Why is this? See, I just define the shards. Why is this not handled by OpenDL
yeah, but
itself internally?
so 2 things. Raft will work, but you will not be protected against for failures. Raft
No,
will
what
work.
he means to ask is why aren't why isn't the controller able to determine where the shards are to be mapped on automatically? Why do I need to define it in module
So
shards.conf?
shard, okay, so let us understand. When you say leader, right, all operations are going to be handled by the leader. So you're going to get lot of traffic on the leader. So as an application design, you have the best knowledge of how the operations are going to be distributed, right? The controller is not going to decide that, or it's going to be dynamic, right? So that part, as an application design, you have to think what are the kind of operations, the number of operations I'm
Yeah.
going to get, and try to then have shards so that this gets distributed to number of nodes.
Another thing is, if you want the data to be replicated on all, by the time you would have noticed that for all the operations, except for reads, all the operations which modify the state machine require a majority ACK. Now, if you keep on expanding, or if you say ODL should decide that this shard to be replicated on all the nodes, your majority has increased, right?
What he's saying is like, suppose you have a 10 node cluster
Uh,
and you have a 3 different shards.
yes.
What he's saying is node selection can ODL automatically do that. If I say like I want to replicate it, I will not specify which those 3 nodes. Can it may be optimized?
Yeah, because say
Yeah, so
those 3
currently
nodes
it
are
cannot
down. So
but
I-
if we can support the dynamic
Yes.
addition deletion, then yes, if you have a monitoring application, you can try all those things. But currently that
Yeah,
dynamic
currently that is not there.
is not there.
What he is saying is, even if I specify it should be 3 replicas, ODL should figure out which 3 replicas.
True. So like I said, it depends on the kind of traffic that you're seeing, right? I just don't want to have replicas where 90% of traffic comes on one shard and then I'm trying to, it doesn't help me. I want to distribute the operations or the CPU to different, or the IOs to different nodes to get a better throughput. So, and that will require what you said, like dynamic addition deletion, right? So that is currently not supported. So it is for applications to dimension how the system is going to be used, what kind of operations, how many operations are going to be done, and then distribute the shards or create the shards and distribute over the cluster nodes.
And also one more thing to mention is, like, say, though it is theoretically possible, I mean, we haven't experimented ourselves in the sense um, uh, the cluster is always assumed to be symmetric. So there is nothing like an asymmetric clustering. So if I understand your question, if I deploy 9 nodes and then, like, say, I give, say, 3 shards put in node 1, node 2, node 3, second shard put in node 2, node 2, node 4, 5, 6, and 7, 8, 9. So is that something what you're looking for?
Yeah, I mean, because it is now given, that option is given to the
Yes.
user, so
Yeah, I mean, you can, yeah, you can do that, but as we progress ahead, you will see that, I mean, there is, apart from storage of data, it also provides notifications, right? Now, notifications of data which, I mean, of a shard which doesn't exist on a node, that node will not
I
get
think
them,
we should
stuff
move
like
to
that.
the next
Yeah.
one where you have that.
Yep. Okay, you guys want to take a break? Yeah, you have a question? Yeah. Okay.
What last you are said, like little. So like all application who's consuming data
Yes.
of that shard should run on that shard, or it can be anywhere.
It should run on that node where that shard is there. They should be co-located.
that
If they are not
That is
co-located,
little dangerous.
So the
so
current
that's what I mean. Once we, why does it happen? That also you will figure out
so
automatically
I think let's move to
once
the
we
next
move
section.
forward.
We'll
Yeah.
come to that, why that is required.
Yeah. But if you guys want to take a, you had a question, right? Yeah. Yes. Majority act for that right to succeed. It doesn't mean that it won't be replicated to all the nodes. It will be replicated to all the nodes, but for the right to complete, I only need majority.
Okay. No. Okay. The whoever has not act, whichever the follower or
Yes.
not act.
Yes. So leader will keep on sending them those append entries,
Okay.
and eventually they will also act back.
Eventually. So then again we'll come into that eventual consistency, right? So because
We'll,
until that
yes.
time that follower actually returns the old value.
Yes, if you read from the follow, that is why
Correct.
reads are forwarded to the leader, because leader will always have the latest data, right?
Reads are forwarded to the leader. I thought only writes are
No, no, no,
forwarded.
no.
Huh?
All the operations are, everything is. Now, by the way, Raft paper, the core protocol
Yeah.
doesn't discuss about this stuff, as in reads and writes. It only discusses about the log. Usually, whatever modifies the state machine, those commands will go into the log. Reads don't have to go, right? Because reads are not applied to the state machine.
Okay, no, that's what. Like, I think I missed that part completely. Like I was
Oh,
always
okay.
thinking writes will go to the leader and reads
No,
can be
no,
done
no,
from
no,
anywhere.
No.
Okay.
Leader.
So
Yes.
load balancing comes
Correct.
by having multiple shards.
Yes.
So because
You
each
need
shard
to
has
shard
its
and
own leader,
distribute. Yeah.
So
you
it
have
is by partition, by virtue of partition.
Yeah.
So we have two aspects.
We'll
right?
go
Like,
into that also,
let's
that
say,
sharding
and
and
then
all.
partitioning. So if I have one shard, now one shard is considered to be one wrapped system. So if I have 10 shards, I'll have 10 wrapped systems running. 10 leaders, 10 follow,
20 follow.
20 followers.
Some-
Yeah, my second question was like what Muthu mentioned, like symmetric. So what do you mean by symmetric sharding here?
No,
Sharding is not symmetric.
Sharding is not symmetric.
Okay.
That means, like, say, typical deployment is like, say, I put the data, if I take a 3-node cluster, all the shards are present in all the nodes. All the applications which act on all the shards
Are also present on all the nodes. Basically, each and every node is completely identical.
I cannot take something like, say, the only problem is, like, say, for example, like say if I change some VPN configuration to which OpenFlow has to react, right? Now this change which is happening in group 2, so let us call this as node group 1, node group 2, node group 3. Node group 1 is running VPN service, node group 3 is running OpenFlow. That guy doesn't know who is VPN, this guy doesn't know who is OpenFlow. But then eventually the changes which I make in the VPN service should somehow go over the cloud and reach out the third node group, right? There is nothing like a common bus which is currently available.
The store itself is used as a bus.
No, that's what is
So
the
the
forwarding is done, right? Like the node group 3 should be forwarding it to the node group 1 that time, right?
But not,
It's not the
yeah.
notification. I have changed something in the VPN. So I have created a new VPN.
Okay.
I do some computation and determine that, like say, so some 5 switches have to be provisioned with 3 flows each in order to make this VPN work. Now, node group 3 is owning the OpenFlow inventory or flow computation plus flow provisioning and storing the flows in its own shard. Now this guy makes the changes. Now the chain notification has to go from node group 1 to node group 3. That bus is not available.
So I think
Yes.
we are discussing something which
Yeah.
we are going to present.
Yeah,
I
okay.
think
So if
it's,
you're discussing later, then you can
Yeah.
actually postpone
we'll
this.
take it up once we come to that part.
Yeah.
Sure, sure. Yeah.
Okay.
Yeah.
We'll take a break.
Yep.
It's probably too dense. But
I mean, this is pretty important, like the
Yes.
whole clustering stuff.
the thing is, the data store API for us, if you deploy in single node or on multiple node, doesn't change, but the cost of the APIs will change, right? On a single node, there is no leader, follower, nothing like that. Writes directly hit the data store, are applied. That's it, done. But now, in case of a cluster, your writes, reads, whatever operations are there, they involve network I/O. Now you introduce additional error handling. You will have to introduce additional error handling in your application, right? Because now you will get failures like shard not available, which will not happen on single node, because I mean the shard will always be there. There is no, the shard is not located on some other device, right? So
Or like what she said, I mean there can be a leader failure in which
Yeah.
say I get some cryptic error which will never happen in the single.
yes,
No, but if you happen to store everything on every node,
Correct.
then
Yes.
the scalability suffers.
yes,
Like, yeah,
awesome.
yeah. So that's not.
So how do we best leverage this architecture and make our application scale? That we'll see next.
But like application and data should be in a same machine. That is like little limitation that we have to see going forward. How we can
Not application and data. So okay, so I think there are proposals coming of how to make it
Yes.
more extensible. What we are discussing is the APIs and the idea of cluster, so that if you write your applications properly, the APIs don't change for you or at application level, but the clustering will take care of ensuring that that information gets percolated to other nodes, and your application design does not have to change once you move to a cluster based thing. Okay, so cluster, I think the main benefit today is about HA, in the sense that you can bring down one node, and if you are return your applications in proper manner, no change is required on the application level. Your system will still continue to work.
All right, we'll take 5-10 minutes break. Yeah,
So maybe 25 will
by 11 we'll be done with that. You don't have to. Yeah.
10 minutes. Okay, so 10:30 will.
10:30 we'll start back.